Hello everyone. Today again we are going to look at motion calculation. I have done the explanation of motion, Newton's first, second law of motion, motion equations, and how to prove motion equations, and also motion under gravity. So today we are going to look at the calculation. The first question says, a car accelerates from 5 meters per second to 25 meters per second in 4 seconds. Find the acceleration. The second question says, a car starts from rest and accelerates at 2 meters per second in 5 seconds. Find the velocity. The first thing that you are going to recall the equations, the formulas. Let's recall the formulas. The first one, V equals to U plus AT. If you are asked to find the velocity, you use this equation. Then also acceleration, A equals to V minus U over T. You use this equation if you are asked to find the acceleration. Then also T equals to, you are looking for the time, V minus U over A. Use this equation if you are asked to find the time. Then here S equal to U plus V upon 2 times T. You also use this equation to find distance. And also S equals to UT plus half AT squared. This equation is also used to find distance. And here V square equals to U square plus 2AS. Wherein you will ask to find the velocity here, V square, when the velocity is double and the T is eliminated. So these are the equations we are going to use to solve these questions. Let's start with the first question. Question 1. We are going to collect data first. We collect data, the information given in the question. A car accelerates from 5 meters per second. That is the initial velocity. So U equals to 5 meters per second to 25 meters per second, which is the final velocity. V equals to 25 meters per second. In 4 seconds, the time T equals to 4 seconds. And you are now asked to find the acceleration A, which we don't know. So we are going to use this equation to find the acceleration. And what are we going to do? We are going to substitute these values into this equation. So A here equals to, the value for V is 25 minus U, the value for U is 5, and the value for time is 4. So our A equals to 25 minus 5 is 20 upon 4. 20 upon 4 is 5. So our acceleration equals to 5 meters per second. So this is our acceleration we are asked to find. And we take question 2. we collect data for question 2. Data. The car starts from rest. So because the car starts from rest, the initial velocity is 0. And when the car goes to rest, the final velocity is equal to 0. So if you have not yet watched that video, check on my YouTube channel. The full video is there, motion complete guide. My channel is Easy Coding 2430. Check and watch the full video. U here equals to 0. A equals to 2 meters per second, and the time equals to 5 seconds. The time is 5 seconds, and we are asked to find the velocity v, which we don't know. So we are going to use this formula v equals to u plus at. We substitute this value into this equation. So v equals to, our u is 0 plus, and a is 2 times the time, which is 5. So v here equals to 0 plus 10. So our v is 10 meter per second. So this is how we solve questions under linear motion. We are going to look at the third question. It's going to be a little bit complex, but the understanding is the best. So let's look at question 3. Question 3. Starting from rest, a car accelerates uniformly at 2.5 meters per second for 6 seconds. The constant speed is maintained for 1/3 of a minute. The car then applies brakes, making a car retard uniformly to rest in 4 seconds. Find A, the maximum velocity, B, distance at constant speed, C, retardation, D, distance during acceleration, E, distance during braking, F, total distance travel, G, draw the speed time graph. As you can see, this question 3 is a little bit complex. So you are going to pay a maximum attention how we are going to solve these questions. So we start with A. We are asked to find the maximum velocity. And we use this formula V equals to U plus AT. We are going to use this formula. So let's substitute the value. Now, and this is our time. Our time is 6 seconds. Because a car starts from rest, our initial velocity is 0. And acceleration here is 2.5 meters per second. And we are asked to find the maximum velocity, which we don't know. So we are going to substitute this value into this equation. So v here now equals to u is 0 plus a is 2.5 times our time is 6 seconds. So v equals to 0 plus 2.5 times 6 will give 15. So v equals to plus 15 is 15 meter per second. So for A, the maximum velocity is 15 meter per second. Then also, let's check the question again. See, the constant speed is maintained for 1/3 of a minute. 1/3. So 1/3 of a minute. We know 60 minutes make 60 seconds make 1 minute. So 1/3 of 60 second, 1/3 60 here to 1/3. Sorry, here is 1/3. So 3 into 6 2 times. So here is 20. So 20 times 1 is 20. So we have 20 here, minute. Okay, so we have 20 because for 1/3 of a minute, the car then apply brakes, making the car retard uniformly to rest in 4 seconds. Here we are asked now to find the retardation. We are asked to find the retardation, also the distance doing acceleration, then also the distance at constant speed. So let's solve for B. Distance at constant speed. We know distance for constant speed, the formula for distance is the average velocity times the time. And we have our average velocity. So D here now equals to, our average velocity is 15 meter per second times the time it takes, which is 20. So our D here equals to 15 times 20 is 300. So this is 300 meter. So our distance here is 300 meter. Also, we are asked to find C, retardation. So we are going to use this formula. A equals to V minus U over T. Okay. So the car then apply brakes, making a car retard. So from the braking point, the velocity there is 15. And we know it starts from rest. The initial velocity, because it apply a brake. Let me explain this part clearly. When the car starts from rest, the initial velocity equals to 0, and when the car go to rest, the final velocity is equal to 0. So the car starts from rest, so the initial velocity is 0. So because it apply a brake, the final velocity here is equal to 0. So let's collect the data. Our v equals to 0, and our initial velocity now will be 15, and our time is 4 seconds. So retard uniformly to rest in 4 seconds. So our time is 4. Now we are asked to find the retardation. So we are going to substitute this value into this equation. So our A here now equals to 0 minus 15 upon 4. This A here equals to 15 upon 4. So our A, 15 upon 4 is 3.75. So our acceleration is 3.75 meters per second square. So this is our retardation. This is our retardation. Then also we are asked to find the uh, distance doing acceleration. Distance doing acceleration. So we are going to use this equation. S equals to ut plus half at squared. We are going to use this equation. So in this case, S equal to our initial velocity, because the car starts from rest, is 0, and our time is 6, plus half A, our acceleration. Let's find our acceleration. Okay, 2.5 meter per second. 2.5 meter per second. Then the time is 6. So 6 raised to power 2. So S here equals to 0 times 6, 0 plus half 6 raised to power 2 is 36. So we have 22.5 other 2.5 times 36. So 2 into itself is 1, and 2 into 36 is 18. Now we are going to multiply 18 by 2.25. So S equals to 0 plus 2.5 times 18. S equals to 2.5 times 18 is 45. So and 45 plus 0 will give 45 meters. So doing acceleration, we have 45 meter. Then also we are asked to find distance doing break. Distance doing break. So let me take this part. Let me take this part. Distance doing break. So we are going to use this formula S equal to U plus V divided by 2 times T. Okay? We use this equation to solve for distance doing braking. Now, what is our time and what is our velocity there? Then also the initial velocity and divided by 2. All right. I'm going to leave this question for you. You are going to solve it and send the answer in the comment section so that I will view your answer and respond to you back. So let's take, so when you solve this one, you'll be able to get the total distance traveled. We have 45 here for distance. Then also distance at constant speed, distance doing acceleration. So when you solve this, you're able to add them together to get the total distance travel. So solve these two and send them in the comment section. So let's solve the last one, G. Draw the speed time graph. Draw the speed time graph, okay? Now let's draw the speed time graph here. We have the vertical and also the horizontal, all right? And at the horizontal is the time, here is time. Then at this point, we have the speed, the velocity. Yeah, supposed to be the velocity. Okay, so the car at maximum velocity, the highest maximum velocity is 15. We have 15. Okay. In how many seconds? 15 and how many seconds? 6 seconds. So if you have your ruler, you can measure. So we take this one and we can say 15, 6 here. 6 seconds. Here is 6 seconds. Okay. Then the constant speed is maintained for 1/3 of a minute. So 1/3 of a minute is 20. 1/3 of a minute is 20 seconds. So we take this one, this, draw here. So here is supposed to be 20. And 20 we add. 20 plus 6 is going to give us 26 seconds. So the last point, then the car then apply brakes, making the car return uniformly to rest in 4 seconds. So we add 6, 20, which is 26, plus 4 is 30. So here we have 30 seconds. So this is a speed time graph. Please subscribe to my channel for more videos and more calculations. We are going to solve problems on motion under gravity, which is the free fall. Follow for more videos, like my videos, comment, share, so that you will be notified whenever I upload a new video.